right. Hi, yes, hello everyone. We are back on a Monday morning stream. Oh, how's everybody doing today? Hi, Igor. How's it going, man? I'm doing pretty good myself. I don't know why, but I turned on the camera and suddenly I feel the need to stretch as if I haven't been up for like 3 hours. But it is Monday. I'm excited. We're gonna talk about this simulation right here. And I'm so excited about it. I started working on this so long ago, and finally we're talking about it. Also, this last week, first video in a while got uploaded. I'm so happy to have that done. Really, it was just everything that we talked about last Monday, but it's been a while since I had posted anything, and I just needed to... I've been working on that video for a long time. It was still kind of rough. I just needed to get it out there so we can move on with life, start making more stuff, talk about this simulation. And there's a reason why I talked about Game of Life before getting into this. But before we really jump into that, I hope my audio is all right. I did last week. There was only one channel, which was a bit of a problem. So thanks for sticking with me, all of you who were here for that last week. It should have audio going into both channels. I should be in both of your ears now. Yeah, once we jump into Blender, I figured out annotations and how to erase those so we can more effectively talk about things. I can draw. I have my drawing tablet set up as a third monitor, so I can actually use a pen instead of just using my mouse to scribble all over the screen, right? Yo, nodding from Patagonia here. Yes, sounds good. Thank you so much for letting me know. Also, Patagonia, that's cool. That's one of the places on my bucket list to go visit. Oh, it always is a little shocking to me how much of a global audience I have been lucky enough to cultivate, because like Blender and graphics and art, it's so universal, you know? I love hearing from people all over the world who are interested in what I'm doing, but also share that same passion, you know? So cool. Welcome, glad to see you. But with all of that rambling out of the way, let's jump into Blender, yeah? Let's get to it. I wanna show off... Hold on, if I can remember what button to hit. I want to show off this simulation, and hopefully we'll get it going all right here live. I swear, I can't talk and read buttons at the same time. Because I have two buttons that capture a screen. One of them is for streaming, and one of them is for making videos. Wow, yeah. Brain's may be going a little slower than it may seem like. But that's fine. I've made this simulation a couple of times now. Once because I lost all of my files. I've talked about it on my Patreon. And then also just to like kind of really figure this out. And we should maybe talk about what this simulation is before really diving into it. So, nothing important. So let me actually bring back that screen. Because I mentioned this is related to Game of Life, right? Some of the inspiration for this simulation here comes from coral, kind of in a weird, abstract way. I wanted to simulate coral reef growth. And I know this doesn't necessarily look like it, but the idea was reefs kind of... I learned by watching GeoGirl, reefs over time expand out into the ocean, and as they do, they build up beach behind them. And so I was like, oh, that's really neat. It would be fun to simulate like this wave of life, like encroaching into the void, expanding out and creating this ecosystem. And that was kind of the inspiration. And after kind of having that thought, it dawned on me, you know, we have Game of Life, we have cellular automata that like like we have this grid, and we have some variables that are being calculated for every point on a grid. Why does that grid have to be square, right? I was gonna talk about Game of Life today and expanding on it and like talking about how you could do that on a sphere and different topologies, but then I realized that's not as interesting to me as this is, and it would be fun to talk about that in the future, but at the same time I was kind of feeling like it's a lot of the same information, it's just now we modify the simulation a little bit to put it on a sphere, whereas this is fully new, but it's similar enough. And when I say similar enough, you can see obviously this is not on a square grid, but it is still a grid. There are a bunch of points all over that sphere that just sit there. And we kind of take some variables, we take whether or not it's alive or not, so the colorful ones that you can see are alive. And then they have a variable that most obviously determines the color, but also is used to determine whether or not, if it's alive, it can spread to its neighbors. And that's sort of the basics of the rules that I have set up. Whereas in Conway's Game of Life, it's like how many neighbors are alive and calculations like that. Here it's more like what are the variables on it and can it spread to that cell? And then it'll just kind of die over time. That the death isn't really programmed in as part of the rules. It's just a hard-coded lifespan. And that's kind of the basics of this. And I'll explain more as we get into it. But that's also the tie-in from Game of Life to this. They're both cellular automata, but I kind of went, how can we make this more organic? So with all of that kind of talked through, now let's finally jump into Blender and play around with this, right? So there we go. So we have new default Blender scene. Let's just do the traditional sacrifice of the default cube, and I tend to bring in a plane, literally, because it's the first thing in the in the list here, and I almost never, whenever I'm setting up simulations, I almost never use the default geometry. And then inevitably I'll be like, well, what if I change the geometry we're simulating on? And then I bring in Suzanne and reset up the initial geometry. But okay, so we've got this. Let's drag out our geometry nodes. Give us some space to work in. And what we're gonna do is just kind of, let's see. Let's start off with an icosphere. I was about to be like, let's start off by setting up our simulation, right? But no, we're gonna start with an icosphere and get our initial geometry set up. So we're just gonna give this some subdivisions. Hopefully, let me know if you guys want me to zoom in more, if you need a different layout or whatever. I have bumped up the scale of the UI so that it's a little easier to see in videos and on streams, but if it's not big enough, just let me know. But we're gonna start off with an icosphere, and then we're going to distribute some points on faces. And this is where we're going to get that grid I was talking about. But of course we need to, well, first off, turn on snapping because we need that satisfying snapping. And then we need to bump up the density, and we don't want random. We're gonna switch this to Poisson. Poisson? I have no idea what language, or if that's a name of some guy, or what this word is, but I always either say in my head poison or Poisson. Anyway, we're going to actually turn up the minimum distance because I don't really want these overlapping, but I do want a lot of them. So there we go. We've got our sphere, and they all have this minimum distance, so it looks like they're overlapping. We can we actually don't have an option for setting the radius, so let's bring up point radius and just turn that down a wee bit so you can see, like, 2. They're not overlapping, which is important. I really don't want them overlapping, but it's not that big of a deal. We're not going to use the point radius right now, so we're just going to get rid of that. Anyway, that is our initial geometry, but we need some variables to simulate, right? So let's bring in a store named attribute node. Rainfall megaton. I don't know what you're referencing there exactly, but it actually is raining here. I'm in the Pacific Northwest, and it doesn't rain as much as I expected it to, but it rains a lot, and it's honestly really nice. Anyway, we are going to we're gonna set up a few variables. Like I mentioned, we need our variable for whether or not it's alive. So I'm just gonna leave that as L for right now. Last time I named some of the variables after viewers. This time I'm not going to, because it's really important that we keep these variables straight, and I need to know what these are. They need to have accurate names so we all understand what they're doing. This simulation actually can get a little messy. I'm gonna try really hard to keep it organized, but oh boy, I've done a lot of playing around with adding in additional variables and bumping up the complexity beyond what we see in the intro graphic. And every time I add in variables, it gets so messy. So I'm gonna try really hard to keep this organized. Anyway, we've got a variable to track whether or not they're alive. We're gonna switch that to Boolean to not set that to true by default. What we're gonna do is actually bring in a random noise, not random noise, but a random value. Set that to Boolean, and we're gonna turn that probability way down. We're gonna put that into selection and then turn the value to true. Cool. Actually gonna turn that even further down to 0.02, and then we can just take a look at this and see, that's still a little high. That's 0.002. That feels closer. Okay. Yeah, that just looks different than I've been playing with, but it'll work. Anyway, that's going to be the number of points that we start off with being alive. And now for the bare minimum amount of variables for this, we need 2. Sorry, I'm doing this by memory just because I kind of want to work through the logic in my head and explain it as I'm thinking it. Because if I look at my notes, I'll just start copy-pasting, you know? And I want to explain the headspace I'm in, explain the logic. If I need to bring up my notes because things aren't working, I will. But for now, we're going to go, we're just going to run with it. So I might forget a thing and then correct myself. Thanks for bearing with me. Anyway, we've got R, which is going to be our resource, okay? So I said that this was inspired by coral and trying to simulate coral reef growth. There's another thing that I did that, another bit of inspiration that the R value kind of draws from, and it's actually from corn and soybeans. I grew up on a farm. I have an agricultural background. I don't know all that much, but I do remember every other year, the fields would switch between corn and soybeans. That's because the soybeans put nitrogen in the soil, corn takes it out. So there's a resource that if you just keep growing the same thing there, they'll deplete the soil, right? And so that's kind of the same thing here. Anytime I was testing this without some variation in the resources in the simulation, everything just kind of fizzled out and died really quickly. And we don't want that. So we want some variation in the resources, the initial resources, and I'll show you how that affects the simulation when we get into setting up the simulation. But that's why we have this variable here. And then we need an age variable. We're going to set that to integer, and every time step we're going to up that, and that's for some comparison stuff, and then later some graphic stuff. You saw in the intro graphic, they kind of got smaller over time. Every point got smaller, and that's because we were comparing the age and using that to set up some fun visuals. So that is kind of all of the initial stuff. We do need a random value for R, but instead of using another random value node, we actually want to use a noise node, a noise texture. This is more important than I thought it would be, because, well, we'll see it when we get into the simulation. I'm trying to explain things here, and we don't even have the simulation to really fully explain it with yet, so let's get into the simulation. This is kind of just the initial geometry and initial variables, so we'll call this initial geo and variables. There we go. So now we can jump into the simulation zone. And unlike Game of Life, we only need a simulation zone. We're going to leverage fields a lot more. Whereas in Game of Life, we kind of needed a repeat zone because of the specific neighborhood. Like, we were... Where's my pen? We were looking at a neighborhood... What? Do I need annotations? I know I can do annotations in here. Yeah, okay. Sorry, thanks for bearing with me. I don't always use annotations, so I'm getting used to that, you know? Anyway, in Game of Life, we had a grid of points, right? And we were concerned with how many points for the given point, this one, how many of its neighbors were alive. And so we had to loop over each individual point and figure out how many of its neighbors were alive in order to do all the calculations. Here we're going to use more fields, and instead of doing all of that, we're going to just kind of check the distance between all of them. Ooh, come on. Can I erase? Thank you. So in order to do that, we're actually going to split up our geometry, and that's going to help make things run more efficient and just make a lot of the calculations a lot easier for us. So we're going to drop in a separate geometry node. And... oh, I'm still using... I'm like, let me select. I'm still in annotate. Anyway, we're going to... trying to think, did we do that before? I think we do that beforehand. Now that feels... hold on a hot second. Do we need a repeat zone? I think we might need a repeat zone. I was just saying how we don't need to calculate the neighborhood, but we do need to look at each living point individually to determine whether or not they will... yeah, we need a repeat zone. Excuse me. Ugh. It's just we're going to handle the neighborhood much different. It's going to be way different from what we did in Game of Life. So, what we need this separate geometry node for, though, is our live value. So let's get a named attribute. Tell it to look at the live variable, plug that in there, and now we're just looking at these as far as our simulation is aware of at the moment, because we just ran only the living points through here. We also want to look at the inverted. We need both of those groups going all the way through. Have you tried using a for each zone? I have. It's... There are some technical differences that make... they can't always be used for, like, interchangeably, right? For each is more efficient, but it depends on what you're trying to do. good question. I played around with it for a while, but then landed on the repeat zone because we need to. Yeah, here's the main technical difference that's involved with simulations, right? So if you're just instancing geometry onto points, if you're just modifying the geometry for every element, for each is great. But if you're changing the variable on some points because of information on other points, it doesn't transfer over quite as well. It's harder to reference separate geometries and do calculations on them and change what's in what group in the for each element, because it just wants to look at the one element and it ignores every other element. Whereas here we're taking one element and referencing a bunch of other elements. If that makes sense, let me know if you have more questions. But that's why we're using the repeat zone, because we want to look at each of our living points, and then based on the variables on our living points, take our not living points and determine whether or not they're going to become alive, and then what variables for the resource variable and age and all of that, what are those variables going to become now that they're alive. Cool, right? Yeah. Hey, thanks. Yee. So, okay, with all of that in mind, we're once again going to take the distance between these, and it'll be better than Game of Life, because we're not going to take the distance between every point and every other point. We're going now, because we've separated them, we can take the living points and find kind of the closest living point, and then, sorry, I'm trying to explain it without doing it. Let me show you what I'm doing, okay? So we need some vector math. We're gonna set this to distance, wherever it is. There it is. We're going to bring up the position, and we're going to bring in a sample index node, because in this repeat zone, we can take the iteration as our index and bring in our live points, because we're looking at all of our live points individually. Then we'll change this from from float to vector, plug that into our distance, and then we can take the position and just plug it straight into the distance node. Reason this works is because we're going to start, like, we're just kind of referencing the position and variables on our living points. But then if any of our non-living points are close enough, we're going to work with them. So because information back propagates in geometry nodes, we're just going to modify the not living cells, and that's why we don't have to tell this which geometry to work on. I hope that makes sense. Let me know if it doesn't. We'll continue, and then I'll be able to show you that back propagation once all of the nodes are filled in and we have all of the connections. So we've got the distance between all of these. So now, of course, we need a comparison, because this is just a value that doesn't tell us whether or not we actually do anything. So let's find that minimum distance, and I'm gonna set it, I forget what exact value we want. This is one of those things that you can play around with, right? But you want it within the ballpark of the minimum distance we set. If you make it smaller than that distance, then no points are within that distance of each other, right? So make it a little bit bigger. It's up to you, because we're going to take any point within that distance and then set them to be alive. So that means that one point can spread to many points if there are a lot of them within that radius. So yeah, that's kind of a control as to how fast things spread. One of several. We're going to have several controls to influence this simulation, and this is just the first one that I almost never use. Anyway, I'm pretty sure that value's good, so that's, let's see, that's our distance, so that's our neighborhood. We also need to let's see, make sure that the age on this point is a specific age. You can't just have every live point spread to other points, because if that happens, like, say we have this wave. Let's actually switch back to the other screen. Wow, if I need to label my buttons better. But so we have this wave, right? And where those small ones are on the back of the wave, those ones are still technically alive, but we've added a variable to make sure that they don't spread, because if they did spread, they would just kind of spread in all directions, right? They would all become alive in proximity to all of the other points, and we don't want that. We don't want that at all. As soon as one dies, it'll become alive again, because then it'll be next to another alive one, and that just, it doesn't work. It doesn't work. It doesn't work for the aesthetic we're going for. So we need to figure out how old is this living point. And we need to do another comparison. Of course, take our iteration as our index. We need another named variable. We need this to be not R, we need this to be age. I'm sorry, a lot of this is going to be just working in the node graph, getting it set up. We'll do some tests as I go along. I won't just set it up and then be like, ah, ta-da, it works. But a lot of this, we have to do a lot of work before we get anything that looks good, anything that shows what we've done. So anyway, we need to find the integer value of the age, and we need to see if it's equal to 2. I found that if it equals 1, things get weird, and we'll set it to 1 for now, and I'll show you what I mean. But we need some Boolean math to make sure that both of these things are true. And then we need to set some, store some named variables, right? Because we've done a lot of checking up on this set of geometry, and we need to set some variables on the other set of geometry, on our dead geometry. So let's get a store named attribute node. Make it so that we can not that one. There we go. Work on this piece of geometry, and we're going to use the live variable. We're going to change that to Boolean. We're going to use the selection and set it to be alive. Then we need we need R. This is where R comes in. We're going to once again sample this index, and in fact, I think I'm gonna bring all of this down here so that we have this kind of column of sample index nodes. We'll figure out in a minute how best to organize this so that it's legible. I say as I start organizing it. But, okay, we're gonna set up kind of the same logic. I need to stop organizing. My OCD is coming out. Stop it. But we need the same logic, and we're gonna switch this from integer to float. And bring in R. Oh, did I plug? Yep. That needs to go into index. Okay. So we're sampling R, and now we're going to switch this store named attribute from Boolean to float and plug that into value. Now we can take this Boolean that says, yes, this one is alive, and yes, we are going to modify these variables, and use it to set our R value so that we're inheriting the R value of the point that was close enough to spread to that point, right? And the idea is that we've got one point that's alive, and it's gonna spread to new grounds. It's going to make these other points alive, and it's going to spread. And because it's the one that's spreading, it's kind of taking its genetics, its variables, and forwarding those variables. So we should have, well, we need to make a material so that we can see what's going on, but we'll have we'll use this R to determine the color, and then we'll be able to see as one point spreads across this globe, that color spreads, and then we'll have another point that's a different color, and it will spread, and you'll be able to see two species, if you will. That's kind of a vague definition, but like, you'll be able to see the difference and see where these variables came from and how they're spreading. Anyway, so those are our initial variables. They're gonna get more complex in a minute, but we're just gonna leave them like that for now. And one more thing we need before we can start running this simulation is to first join our geometry, right? Because right now they're separate and we only see the living points. Now we see all of the points. And we need to set our age. So we need one more store named attribute, and switch this to integer. We're going to say this is age, and we're going to take our age, not that node. I can't type age into the thing. I need the named attribute. And now we set this to age. We do one more comparison. Or no, we don't need a comparison. No. We need another named attribute. Take our live attribute, plug that into selection, because if it's alive, and we need to compare our age to some maximum age range, right? We need these points to live for a certain amount of time and then they'll die, essentially. So we'll just set this to 24, because why not? And eventually we'll add another variable so that they can have a variety of maximum ages, but for now we'll just set it to 24. That's the number of frames that these will stay alive, and afterwards they will die. So if age is less than 24 and it's alive, so we need another Boolean math. Then we will take age and we'll use an integer math, and we'll add 1 and set that as age. Yes? Does that make sense? I hope that makes sense. Let me know if it doesn't make sense. But cool. Hold on. I'm just thinking through it. I mean, we can just test it. I'm trying to think, is that something we do now, or do we need to do that in the repeat zone? I think doing it now is fine. So let's just run the simulation. But, well, we're not really gonna see anything. So we need to set our material, make a material. There's a lot of setup before we really get into showing this. Let's call this SimMat. Come over here, attributes. We need R, and we're gonna bring in a hue saturation value because I don't know what color this would map to. I don't want to use a color range node because eventually our value is just going to increase. You know, I'll explain why we're using the hue saturation value node in a minute, because it's not exactly relevant right now, but it'll help get an interesting visual, which is kind of important. So we'll set that to base color. We'll also put in the emission, and we'll set a strength of 1 because I really want to see these glowing, right? Let's switch over to shade preview. Give it a hot second to recalculate all of the graphic stuff. it might be done. It's hard to tell. Sometimes it needs a moment and sometimes it's fine. Anyway, right, it's not showing anything because we haven't set the material. Now we've set the material. Hold on. There's one thing I forgot because we don't want to see all of the colors for all of these guys. We also need the live value, and since we don't have booleans in shader graph, but we do have floats. That's what this factor is, and anything that's not supported here, like I'm pretty sure integers and booleans, those become floats essentially. So we can use our boolean as a float and do a little bit of math. And what we'll do is just use a mix node. Want a mix color node. We'll use this as our factor so that A is whatever. So when this is, well, when this is 0, it'll be A, if I'm remembering correctly. So we want this in B. And then when it's 1, yeah, when it's 1, that'll mean that it's alive. So we want, yeah, we want this in B because it's 0, 1. When it's alive, we'll use B. When it's not alive, we'll just go to black. I guess I could just separated geometry, or it doesn't matter. Anyway, we're going to use that for color, and now we should see, yeah, okay, cool. Cool. We've got only a few of these actually showing up as being alive. We can only see a few of them in their color. Fantastic. So, fingers crossed, when we hit play, this should work, and since it's not the full simulation yet, we won't see all of the same behavior, but we should see those colors expand. That's kind of the minimum. And I want to say what I expect, because I want to be like, yes, we've done this correctly, not, oh, happenstantially. This does exactly what I expected it to, because you can't tell me that I didn't say that, because I didn't say anything. I don't know. Anyway, prediction, the colors should just expand. Yeah, so let's hit play. Okay. What? That's not right. What the heck? Is the distance wrong? Are these... Oh, okay. Yeah, the distance, it's set to greater than 0.02. So we need this to be less than or equal. So that it's anything within that radius of that point. Since it was greater than, all of them just became the same color value as the point that's alive with the lowest index, because that's the order that we were calculating in, right? So, oops, let's try that again. Okay, and we see a whole lot of nothing. So let's reduce this radius just to make sure it's not still a radius problem. And I guess we'll keep track of that point there. Reset. Oh, what the heck, man? What have I done wrong? Oh, I said that we were going to leave our age sample at 1, and I also mentioned that that doesn't work, and I wanted to show why that doesn't work. It doesn't work. This is a different error than I was getting before when I had it set to 1. So let's just set it to the value that I know works and see. Okay, well that's reassuring. 1 point spread, which isn't the desired result, but it's a step in the right direction. So, okay, what is... okay, other thing. There are so many little things that it's easy to forget about because you set them up once and then you just play with the rest of the simulation, right? So the example here is we need the number of iterations to be greater than 1 to start with, and we actually need it to be the number of points that we plan to simulate over. And since we're going off of the alive points, we need, in between this separate geometry and the repeat zone, we need a domain size node. And very importantly, once again, we need to set this to point cloud because we're working on a point cloud. So now, well, don't break that connection, actually. Thank you. Now it knows how many iterations to do every single frame. Because again, in the repeat zone, we're doing that X number of times every frame. So now that we've got all of that taken care of, I want to say confidently that this works, and we should see the colors spread. It won't be, again, won't be the full simulation. It won't look exactly as the example, but the colors will spread out. Ready? Yeah. That's what I get for trying to explain this live. What other little details have I lost? Are other points spreading? It looks like no. We've got some spreading. I don't want to reduce that radius down much. No, it's not reducing the... I'm a dingus. I don't want to keep reducing the radius. I want to expand the radius, right? Okay, so now, there we go. That's the behavior we want to see. Fantastic. Now we do have a problem where it's not expanding much, and one of the best places things happen. Hey, thanks. I appreciate it. Yeah. But okay, so we've got this spreading. And fortunately, I know what the general issue is here. So let's take a look at our noise texture, and we can see that we have a bunch of little bitty patches of different values, right? So, wait, we haven't implemented that part yet. That's not the problem. It's gonna be the problem. And I'll explain why. So I was talking about corn and soybeans earlier, right? So another reason why we have this is not just to drive the color. Right now we're just having the points inherit this R value to drive the color so that you can see the spread of the color, right? The more crucial reason we have that is because we're going to take the difference, just like we found the distance here to see whether or not it spreads. We also want to take the distance between these because we're looking at the corn and soybeans. If there's too much nitrogen, soybeans don't grow. Okay, I don't know that that's a true fact, but run with me here, okay? There's too much nitrogen in the soil. The soybeans have been growing in the soil too long. They can't grow anymore. So you need to put in the corn. The corn depletes the nitrogen. And then there's not enough, so the corn can't grow, so you put in the soybeans. So there's a difference, an optimal difference in the amount of nitrogen between one phase and the other that it allows the two different species to grow, right? That's what we want to do with our R value, is establish a difference between the spreading cell and the dead cell, the colonized cell. We need a sufficient difference in the R value to be able to spread. And that's where the interesting dynamics come from. That's where we get beyond just a patch of color spreading and we get into more interesting dynamics. Which is why I was looking at this noise texture and I was gonna say the amount of noise is too much. We were gonna make that smaller so that we have larger patches of similar values so that they can propagate more freely, but that's not the case at the moment because we're not even using that mechanic. Reaction diffusion. Exactly! Hey! Well done! This is an over-engineered reaction diffusion simulation. Yes. It's amazing how much in nature like how many things in nature behave with reaction diffusion mechanics. If you look at them at different time spans. And that was also part of the inspiration here. I think I even wrote a post on my Patreon, literally just titled Reaction Diffusion, or maybe it was a project file that I shared with my patrons titled Reaction Diffusion, trying to get this to work because I was like, oh yeah, coral expanding out is kind of a reaction diffusion. Different, there's so many different things that interact in nature that if they're not directly reaction diffusion, they behave in a similar way. Beautiful. Thank you. I appreciate it. It's also good. I want to pivot into doing a lot of nature-inspired sims, and this is kind of step one into that, right? We started with Game of Life, now we're doing this, and then I have ideas for future streams and future videos of taking this simulation and layering it up to build like ecosystems. Right? Right? Game of Life becoming reaction diffusion. That's actually maybe the best way. That's a great way to explain what I'm trying to do here, and maybe even will become the title of the video talking about this, because a lot of people... It sounds interesting if you don't know what reaction diffusion is. And if you do, you're like, oh, how do we get from here to there? So that's... Thank you for that. I might steal that as a video title. And for anyone who doesn't know, hey, sorry, if you don't know what reaction diffusion is, it's this it's this process through which we get the different patterns on animal prints, and like Nile Red has a great example of it. Sorry, I'm trying to pull up a new tab so that we can maybe take a moment and look at some reaction diffusion videos, just because it's neat and I want to make sure everybody knows what we're talking about here, right? So I actually want to pull up Nile Red's video, because I'm pretty sure he has just a video showing it, and if he does just talk about it and explain how he's doing it, then we'll just cut to showing it, because we can talk about the chemistry, but I'm not a chemist. Ooh, yeah, okay, hold on. I hope... Let me just make sure I'm not ignoring chat. I don't want to ignore chat. But yeah, we're gonna just... I want to mute this. Hold on, I'm gonna pause the music for a hot second.
Today,
Yeah, Can we just skip to here-ish?
water and sodium bromide, and it almost immediately turns yellow. This is just a bit of bromine forming, and I'll have to mix it around, which is some ferroin indicator.
Aha!
I also have to mix this around until it looks pretty even, and after that, I just have to wait.
Is this the fun? Are we
at
at the fun
first,
part?
not very much was happening, but then I started seeing some small little spots appearing. Even more of them then started popping up,
okay.
and they were all getting bigger and bigger. What's going on here is called a Belousov-Zhabotinsky reaction, and it's still one of the weirdest reactions I've ever seen.
It's so beautiful. That's... reaction diffusion is so good. This is just kind of on a time scale that we can really appreciate it, but in my opinion, a lot of nature is just... It can be broken down into reaction diffusion mechanics. I could just be making stuff up, though, because I don't actually have an ecological degree, or a biology degree. I do graphics, and I like patterns. I'm a geometry guy. This is pretty geometric. I see a lot of reaction diffusion in life. Jaw-dropping. Right? Right? Isn't this incredible? And this is also a great a great visual to show why we brought in the noise here, because if we just took all of the colorful points, right? Let's turn this back off. If we took all of these colorful points and let them just spread out, well, first off, as we're looking at it right now, they would just spread off and stop. There's no reaction diffusion going. Once we set up the reaction diffusion, they'll spread out, but if there's nothing to incite another reaction inside of that, like, circle that forms, inside of the circles that are forming here, then we won't get another wave. So we need a noise texture to make it so that there are regions where that difference, the difference between the two values that I was talking about a moment ago, isn't that optimal amount, and so it breaks that wave. We get a circle, and then it breaks up at the top here, uh, so that we get a region where another curve can like come in and fill that spot, and then we get this reaction diffusion. I hope all of that made sense. this is this is what we're going for. So, with all of that said, what the heck is going on here that's not letting that happen? And let's reset the simulation. Interesting, okay. Because we did change this value, this scale of our noise. But like I said, that wasn't really driving anything. I just wanted to make sure that wasn't part of the problem for an unknown reason. But yeah, we have very little spreading. Do we need to bump up this value? Like, that might just be a band-aid, but we'll see more spreading. Okay. Okay. Yeah, I might have just needed to bump up the value because we got to a point where all the islands were a little too far apart. There were just no points within that radius, so bump it up and we should be good. Now this will spread everywhere eventually. And the reason this is slowing down is because every frame we're increasing the number of living particles, right? The number of living cells. And that means that every frame we're doing more and more repeats. So here in a minute, we'll find another way to limit the amount that we're doing all of this. We want to do a little bit more complex Boolean math here and not just take the living the living cells and split it apart. We want to be more specific about which ones we're going to loop over. Anyway, with that solved, and we have a noise texture that's at a better scale, what we're going to do is introduce that difference I was talking about. So we just need a math node, and we need to take this. Is it this minus that? Well, we'll go with this minus that. Get that difference, and now we need another comparison, just like we had with our distance. Our difference needs a comparison, and we need some value that this has to be greater than. You could do it less than, but it doesn't quite work the same or as well, so we need it to be greater than or equal to, and usually one works. If I do things wrong, one won't work, but other values will work, and that's a little bit of a litmus test for whether or not this is going well. Oh, also, now that we're done watching that, let me turn the music back on. Yeah, there we go. Let's vibe. Vibing on a Monday morning. So, okay, we've got another Boolean to keep track of, so we're going to start building a chain of AND nodes, which feels ridiculous, but kind of how it is. We have a list of criteria, and we just got to make sure that they're all being fulfilled in order to propagate. So now we should start to see some reaction diffusion, but we don't have... Actually, one more thing before we hit play. I forgot we actually need 2 store named attribute nodes, right? So we're adding our age, but we need to turn things back off, right? And that's the other half of the reaction diffusion. We have to switch states. So right now we're just making everything alive and incrementing our age. We also need to reset the age back to 0, and hold on, I can't with the music at the moment. Not that one. I'm also going to turn this down just a little bit. It's loud on my end. I hope it's not too loud on yours. But we're also going to skip forward for a song because I'm not feeling that one. Not gonna lie. Okay, getting back to it. So we need another stored named attribute so that we can reset whether or not they're alive. So if our age is less than 24, we increment. No. No. No, this is going to become redundant because what we're going to do is say if the age is greater than our maximum age, we'll kill them essentially. We'll turn off the point. We'll turn off the cell, which then makes this redundant. So it'll just be if it's alive, we'll increment our age, and if the age is greater than our maximum age, then we'll reset the age and we'll toggle off our living variable. And of course, since this is a Boolean, we gotta reset that to be a Boolean, leave that off. Now this should work. Now we should get a wave. Whether or not it propagates well and is beautiful is another question. How closely it looks to our example simulation that I've already set up is yet to be determined, but we should get some wave action. All right? Or we get nothing at all. Ah, why? Why? Let's take another look here. So, okay, all of that looks fine. Let's try setting that the other direction. That should be wrong. That should not work. That should not work. Sorry, I need a moment to think through this. Because I've gotten this error before. How did I solve it before? Set that back to greater than or equal. We've set our live parameter. Gonna take a moment to also just clean things up a little bit. What the heck, man? We'll also want to switch this to 4D, and that's just so that we have this W parameter that we can use as a seed for this toys network noise texture. So that we can scrub through that and get a variety of different simulations by plugging in a different variable there. Yeah, what the heck? What's going on? I don't want to pull up my notes, but debugging therapy, yeah. This might take a while to debug, so instead of doing that, what I'll do is just pull up another instance of Blender and take a look at what I've done before. That way we don't have to sit here trying to solve everything. Eventually we'll probably do some streams where I'm doing new things live, and I will just kind of have to sit here for a minute or two in silence, but I don't want to do that right now. I do so much just sitting and thinking whenever I'm working on new projects, because I'm like, okay, hold on, how does this math work? How does this math? Actually, it's one of the reasons I have a great big whiteboard behind me, which I love. I'll just, if I get stuck, I stand up and I start just scribbling absolute nonsense on the whiteboard back there, and it helps a lot. Or I'll talk to my dog. I rubber ducky with my pup. I just tell her what's up, and then eventually the thoughts just kind of come out. Let's close that. Like it all starts to make sense, you know? Anyway, I have the other version pulled up now. Don't need that. Do. So let's take a look. Blender, please open. There we go. Okay. Sorry, I'm not going to show this on screen at the moment. I just kind of want to see, like, am I making a silly mistake, you know? Like, surely. No, that's a later step. Oh, actually. Sorry, give me one moment here. I think I see the problem. I think I see the problem. Okay. Okay. So, subtraction, right? One of the things that can happen when you subtract two variables, two values, if you don't know which one's the bigger one and you subtract them in the wrong order, you can get a negative. That in and of itself is not groundbreaking, but we do have to account for it. So the way I did that is just by dropping in an absolute value here, and now we shouldn't get negative values. It doesn't look like we were, so I'm not sure that'll solve everything, but it is something we needed to do and we needed to account for. So let's hit play, and we still see nothing. Okay. Well, that's not quite it. I swear, I've done this simulation several times over the last few weeks, trying to tweak it, trying to modify it, trying to really just... I find when I redo projects, it's nice practice, but also it helps come up with new ideas as I'm going through the process, because I'll forget what I did in earlier steps to get to the point where I'm at, and if my notes aren't good enough, I'm still... Take good notes. Notes are great, but if I don't have good enough notes, then it'll be troublesome to get from A to B again without my own guidance. My past me's guidance. But the point of doing that is to find other solutions and also try and optimize. I'll find, like, I'll have done something months ago. I go back to readdress the problem and go, wait, since then I have learned XYZ, or I've discovered this other node, and I'll be like, I have an optimization, and we can do things faster now, which is always great. Or it goes in a different direction. I get different art, which is also fantastic. Anyway, what the heck? Maybe I will just show this because this is a mess, and we'll get there. Actually, this is a broken version. Not a broken version, just not the best and not the final version. This is the version, though, that animation from the beginning of the stream was rendered with. So it at least does, like, the basic simulation, but there are better ways to handle some of the things to get more interesting patterns, or at least more stable patterns than the intro animation had. So, okay, we have the absolute value in there. We're not doing that. That's redundant. Not alive is also redundant, because these are, by definition, not alive. Random values, not doing that. Yeah, we did that. Adding 1, if it's alive, yes. I don't see anything different. I mean, I see a lot of differences, right? But for the stage where we're at, I don't see any difference. And I don't know why the values aren't spreading, which is concerning. But that's fine. That's life, right? So, okay, let's just take another look at the setup we have here and talk through it one more time, right? So we have our initial geometry, we have the distributed points, we have the 3 variables that we need right now. We've got our random value and our noise texture all set on the right variables, I mean, and these, yeah. It starts off with the right variable. I'm actually gonna reduce this now that I'm looking at it again. Let's cut that in half once more. I just want a handful of points here that start off alive. That's still way more than I was getting in my other tests, so it's fine. But okay, we've got all of our initial stuff. This, you know what? Where are we comparing our age? Let's break this. At one point I was doing this in here. Let's break this out and use that for our separate geometry, right? Because we only care about whether or not the point is going to spread. And so we should use that to separate the geometry. We should only look at the points that are going to spread instead of looking at the ones that are alive, because those are, well, yeah, spreading is mutually inclusive of living, but we don't need to look at all of the living. A weird sentence that I don't know, that's become run-of-the-mill for me in these simulations, I guess. Anyway, what we want to do is do a comparison, do some Boolean math, set up kind of the same thing. We're going to take our age, and we're going to integer. This is going to equal 2, because that's the age at which they spread. Make sure that both of those are true, and then feed that into our separate geometry. And we're going to label this. What should we label this? This is going to be spread test? That feels wrong. No. Propagate check. I'm sure I'm misspelling that horribly, but it's fine. Anyway, so we've got that, which means we can get rid of all of this and that, which simplifies our Boolean logic and makes our nodes a lot easier to read, which is pretty good. Also going to just clean this up a wee bit. Grab that. Do. Giving everything space while I'm trying to think through all of this, because this is still not exactly working. I mean, that shouldn't have changed anything. It didn't change anything. And why the heck not? This should be the bare bones, the absolute bare bones of this simulation. Or maybe I just haven't added enough, and therefore there's something that we're missing that I thought was a later step. It can be hard to tell sometimes. I mean, I can bring this value up. Or maybe we decrease it since we're looking at greater than or equal. So we'll bring that from 1 to 0.5. Yeah, what the heck is... Nah, we're gonna look at the older version one more time here and kind of talk through it again. So we have our initial geometry, we have our initial variables. We've got our more primitive separate check. Don't mind all of this. That's spoilers. So yeah, we've got all of our sampling. Distance is less than whatever. Got all of our Boolean logic again. That's irrelevant. Yeah, I don't know what the heck is up. Why aren't you working? Yeah. this should all be about the same. I mean, I can keep adding to the simulation because, again, like, there might be... Yeah, that doesn't make sense. That really just doesn't make sense. I guess this is also partially why I wanted to stream, because, like, I show off in the videos, look at this cool thing I made, but it erases all of the, like, sometimes months of work I do, like, researching and learning and testing and iterating on all of these projects, and then I'll go back to make things for a video and run into some older problems again, which is also why I'm like, yeah, I do these a few times for a number of reasons, and it's partially because I'm like, I need to know that what I'm saying is absolutely true for the video, and I'm not just lying because I think I know how this works and I forgot a detail, right? Because I want to share working things with everybody. And this is not that at the moment. And why? Why? What the absolute heck? That is life, though, you know? But okay. Is that part of it? Are we resetting the age too soon? I don't think so. Yeah, no, if that's greater than or equal to, then we reset. Oh. Oh, I found it. I found it, and I feel so dumb. Mostly because I've done this before. Okay, here's what I've got. Here's what's going wrong. So we're resetting our age and the living variable here, right? It's important you do that in the correct order, though, because if you reset the age to 0 and then say, hey, is the age greater than 24? If not, reset it. So, okay, we gotta switch the order of these two. It happens, yes, sometimes the silliest thing. I know. Hey, thanks for going on that journey with me. I really appreciate it, because, yeah, that is the silliest mistake, and I have made that so many times. But I'm just glad that it's something that can be easily fixed, you know? It's a silly mistake, but also it happens to the best of us. You reorder the nodes, you reroute everything, it's fixed, we're good. Okay, so now, just by switching the order of those nodes... What the heck? Why? What do you mean it's still not spreading? That should have done it. Okay, hold on. Let's just turn those off real quick. If you're not aware, hit M to mute nodes. Okay, and then after 24 frames, they all just die, which is expected. Or I'm just... Okay, they just turned off a moment ago when we passed 24 frames. Is Blender gaslighting me? What the heck is... Nope, that's not the button I wanted. What the heck? Okay, we reset them and that's when they turned off. Blender is not gaslighting me. That was mean. I'm sorry, Blender. No, why didn't... Okay, let's take another look at all of these, I guess. I don't know what else there is to do, but just keep looking for bugs. Because clearly we have bugs in the wiring. both of these criteria are met, we set it to be alive. We store the R value. R is just for resource or random. I think I said when I was first making this, I was just like, I need a random variable, and I set it to R. Clear cache. That's yeah. I mean, I don't have anything cached other than like just playing the simulation, but by resetting it, since I haven't changed anything, it's not going to clear just yet. I don't know if there's a manual way to do that without changing these nodes. That's a good point, though. I appreciate it. Maybe some clamp check on a math. Ooh, oh, bud. I don't see one. That's a good catch, though. That also trips me up every now and again. I appreciate it. But no, I don't see any clamp. That almost made me think I had a clamp for a hot second, but nah, I don't see any of that. Like this? Oops. This should work. Full stop. This should work. I mean, we could increase the distance again. I mean, we know that 0.05 distance works, though. Now, let's leave that at 1. Let's switch it back to less than or equal. And it does spread at less than or equal. Actually, that was it. That was... I've also run into that before, where it worked with this inverted. But it shouldn't. It absolutely should not. Like, in this older version, yeah, it's set to greater than or equal to. So what? We're going to run with it. We're going to run with it for now. And I'm sure in a minute, I'll figure out why it is that that's inverted. Because that is an issue, but it technically works. It's technically correct. The best kind of correct. So, okay. Hey, we have it working, right? Let's reset that. We get propagation. We get a wave. In fact, I'm going to expand this so we can get a better view. Hey, step 1. We did it. Fantastic. But that's not the full version, right? Like I said, these expand, they shrink, but now we have all of these regions where things can't, like, invade again. And that's a problem, because then it just kind of falls off, and all of our points are dead, and we can't continue the simulation. Awesome. Thank you. I appreciate it. Sorry that took me so long to find that one toggle to make it work, but, like, that's life. Thanks for sticking with me for that. So yeah, it works, but that's not the full sim. We have a little bit more work to do. In the meantime, though, let's actually make this look a little nicer, which is pretty easy, right? So we have this wave, right? And right now we're looking just at all of the points. In our initial simulation, and since it's been a minute, and if people are here who haven't seen this just yet, this is the simulation we're trying to make. I hope you can see the resemblance, but in this example, we don't have all of those points visible all of the time. They're all there for the record, but they're not all visible all at the same time. So let's fix that. Let's do some tweaks, do some math with the variables we already have, and get closer to this visual. By the way, I made the texture, the material for all of the points here, but this kind of rocky looking texture, courtesy of Ducky3D. If you're not familiar with his channel, he's really cool. Definitely check him out. Not sponsored. I don't know if I have to say that, but like, he makes cool materials, and I bought his real-time materials pack because I don't want to focus on materials personally, and he does a great job of making some really cool ones that are all procedural and they're fun, so check that out. Anyway, getting back to it, let's make this look a little closer to that. So, how do we do that? Well, the way I'm going to go about doing this is just kind of by scaling all of these down, and in fact, just scaling them by the age value. And fitting the age from 0 to whatever our maximum age is, which right now is set to 24. So in order to do that, let's drop in a map range node. And we're just going to take our age variable, plug that into the value. We're going to turn off clamp because we don't want to clamp because we need some water. My throat is getting dry. Excuse me. Okay, so we need an integer value to drive both of those endpoints, not 245. That is a long lifetime for a point. I don't think points typically live that long in the wild. Anyway, so that's going to go from 0 to the maximum age of our points, and we're going to just put that into the 0 to 1 range. Then what we can do is bring in a curve to float node. Where are we at here? Helps if I can spell things, right? Or float curve. Why am I looking for curve to float? No, float curve. Okay. We're going to plug that into our value. Let's... I'll make this look better in a moment when we see it on our waves of particles, but we're going to use the float curve, and we're going to set the point radius. Let's do that outside of our simulation. There's no reason to mess with that in the simulation. We'll just do that before the material. And let's actually drag... Well, we'll drag the float curve over to where it's a more reasonable spot. And, okay, so this is just going from 0 to 1, quite literally, for the scale. So let's add in another math node, yeah? Let's add in a math node, and we'll just set this to multiply and bring it down to... I think the default size for a point is 0.05? That looks right. I guess it doesn't super matter, so long as it looks alright, and that looks way too big. So, yeah, we'll just leave that at 0.05. I think that looks pretty good. And we could just leave it as this, like, neat abstract floating clusters. Actually, I want to watch this go. Ah, that looks cool. I love it. But it looks a little abstract, and it can be hard to tell like where these points actually are when you can just kind of see through this sphere. So instead of doing that, what we're going to do is, well, we're not going to bring in join geometry just yet. We're going to take our icosphere from the beginning here, drag it all the way to the right. And add in a join geometry node. And we'll do that after the set material because I don't want to set this same material to our sphere. And then that'll go to the output, and wow, would you look at that? We have our points on a sphere. It's looking ever so much more like the original example. And we can reset that, and we'll see them. Whoop. Fantastic. We're gonna set shade smooth. So many S's in that node name. Set shade smooth on our sphere. That just looks a little bit nicer. We could even debating upping the subdivisions on the original one. Of course, that'll give us more. Well, yeah, I wouldn't change processing time for our simulation because we're distributing points on the faces, but that doesn't, like, that's all done before the simulation, and we'll have the same number of points. So yeah, that'll, yeah, we'll just bump it up one more because it drives me nuts when in a render I can see all of the individual lines, and at least right now I can when zoomed into that, but when we zoom out, can't see it, and I could see it with 4 subdivisions, and it just looks bad. Maybe not the best to always leave everything on maximum subdivisions and maximum resolution, but like, whatever. My PC can handle it. Famous last words. So, okay, we've got that looking just a little bit nicer, and that's so much fun. Oh, that's so much fun. I want this. Wait. I just realized. Our ramp is backwards. Or our curve, I mean, is backwards. Is there... No, I can't just flip this. There's no easy button for that, I don't think. Darn. But we wanted to go from 1 to 0, not 0 to 1. Well, okay, let's get into the weeds. We do want them to start off at 0, because if they just became alive, like we don't... When we start off at 1, we get all of the dead ones are at full scale, which is not what we want. We want them to start at 0, go very quickly up to full size, and then slope back down to 0 as they approach the end of their lifespan, which sounds so dark when I say it out loud like that, but yeah, that's better. That looks a lot nicer to me. Let's squish that closer to the beginning of the lifespan there, so we get a smoother fall off. I mean, if you really want smooth fall off for these, increase the lifespan, I guess. Yeah, I think that looks nice. Better than what we had it a moment ago. So, okay. That's looking better. That's looking closer to the desired result. Now we just need to, well, we're gonna figure out why this is wrong. But not right now. Instead, we're going to turn down the scale of this and see if we can get some of these points to break up. I also just want fewer points. Why are there so many points on here? Like that? Why are there so many living points that we start off with? I only want like 1 to 3, but we had so many. Because, yeah, we see all of these rings, right? Earlier I mentioned that we need the noise texture on here to make it so that there are differences in the amount of resource, in the value of the resource. Which is why we need to modify this value. Cool, talking through it helps. Well, what we're doing right now is we're creating a random noise texture, and all of these values go from -1 to 1. -1 because I turned off normalize. If you turn on normalize, it goes from 0 to 1. Since we're worried about the difference, and this might be why the check on our value here is inverted. Since we want a difference between them, we want to increase the total range here. And that'll... Let me do it, and then I'll see if I can explain it a little bit better. So what we're going to do is bring in another math node. We're going to multiply and make it so that there is a greater difference between the values of all of our living points. So we're going to multiply this by 6, actually, to give us... Well, now they're all nice shade of blue, but hey, would you look at that? Since we're looking for a distance that's smaller than the the greatest possible difference between the different living points, they can't spread out evenly in a circle. They'll run into regions where that distance is either too great or too small, depends on which direction we have this comparison node set to. But there will be regions on the sphere that they can't propagate to initially. And so we get these expanding circles that then break up. And that leaves areas for other species to invade into previously colonized points and expand again. And so we get these fun, intricate swirling patterns. So let's let that play out because that is the simplest possible version that makes me happy. We can take this further, and we're going to in a minute, but for now, I just want to watch this go, because it's been an hour and a half since we started the stream, and there was a lot of debugging, and I just want to enjoy this. It does look like it peters out. No, we still have some going for the whole duration of the simulation. I like to bump up the number of frames here because I like the long simulations. They are fun. So let's let that go. That's pretty good. I'm pretty happy with that. And the way we can control the amount that like it breaks up and swirls around. I think it did just die. Okay. Yep. Okay, so let's tweak some of these variables. I want to enjoy this for a moment before we get into advancing the simulation. But as I was saying, one of the ways we can control this is by bringing the scale down. Let's just take a look at what this is. Excuse me. And I was going to try and see if there was a good way to visualize the black regions, but not without putting in some effort. Because these are all different values too. It's just since they're negative and we're looking at a float, we don't have a good way to visualize that at the moment. But we can adjust the scale, and the smaller this goes, the larger regions of similar values we get. If we crank this up, the more distorted everything is, and the more breakup we'll get, but we only want so much breakup. So let's try this at 0.5 for our scale. And we're going to change the seed value of which points are alive. And let's hit play. Yeah, I love it. That's... are you gonna... it petered out. Okay. Okay. So, I guess that is going to happen right now. As our simulation stands, it'll basically always peter out, which is less fun. And one of the ways that we can avoid that is by changing the value of R that gets spread to the colonized points, right? So if we change that over time, then there are more opportunities for them to spread into regions that have already been spread, because all of these points... Let's take a look at that. Sorry, I keep breaking off my trains of thought. I want to show you what I'm thinking about. All of these points get their R value kind of permanently set until it re-spreads to that, the live points spread to that region again. So let's actually take a look at that. And we're going to mute the set point radius so that we see all of our points. And we're going to take a look at R specifically. So we'll set material. Well, we don't need to set the material, but we need the named attribute, and we want to look at R. Since R is... No, we're not going to use the viewer for this. We're going to just modify the material here. And we're going to skip the mix. And that looks cool as is. So this is all of our R values. The colors don't mean anything other than a difference in it. And this is that noise pattern, but with all of the R values used to derive the color, right? Instead of it just being black and white. So what we should see is that one point will start with a color and then that color will spread. And eventually this entire sphere won't have this neat swirly pattern on it. It'll have large swaths that are the same color. And once basically the entire sphere, it's possible that there will still be patches that kind of look like this, but basically in the entire sphere will become just big patches of the same color. And then we'll modify the simulation so that it isn't just big patches of the same color and they can override each other better. But let's hit play. And yeah, we've got... Oh yeah, I didn't even think about that. They're gonna stay within their own color bands. Oh, that's so cool. It's kind of like a flood fill. Oh, that's neat. I love that. Genuinely, I've never looked at the simulation this way before, so this is really fun for me. I didn't consider that as a flood fill algorithm, like in Paint or in Photoshop, where you use the bucket tool, the fill tool. This is that. So we've got a couple of different algorithms that this is kind of parroting. Ah, that's so cool. I love it. But it's not that interesting because we fill in as far as we can until the difference is, well, all of the points with the appropriate difference in their R values are all the same color. And then we move on. So now we need to figure out a way to get these colors to change. So hopping back into geometry nodes, what we're going to do is introduce some variety, or at least the potential for variety. This is where I'm going to switch mindsets a little bit and start thinking about our R value as like a gene. Again, going back to the initial inspiration, I was thinking about coral reefs kind of spreading, and so I've got this biological framework that or mindset really, that I'm working within. We're going to consider the R value a gene, and we're going to give that gene a random chance to mutate, to change, so that it needs a different difference in the resource. Not a different range of difference, but it'll itself put down a different R value. You'll see what I mean. Give me a hot second, okay? So what we're going to do is drop in a random value node, and we're going to put in a switch node, set this to float, because this is going to switch what R value gets saved when a point becomes alive. We're going to have the false value just be the same thing as what we've been doing. Okay, so if our switch value is false, we'll just keep doing what we're doing. We're going to change this. Well, no, we're going to duplicate this random value, and we're going to change this to Boolean. This is the probability that our switch will turn true or false. Okay, so we're going to set this to a very low probability because we don't need it to do a whole lot. We're going to set that to 0.02. We're also going to bring in time, scene time, because every frame we want a different random chance. If we don't do this, it'll just go off of this seed value and the ID of our point. So every point will have the same probability of changing every single frame. We don't want that. We'll get the same repeating pattern. It just won't be interesting. So instead of doing that, we're going to plug in our frame as the seed. And then let's actually get two random values, because if we take our frame, plug that in as the seed, you can see here we have a little dot, which means that this is a field that's using the same value for every single point. Okay? But it outputs a diamond without a dot, which is a field, but every point, every element in this domain has a different value. We can then take that and plug it into another random value node, which feels redundant, but it's not. And we're going to set this to be negative 100. I just want whatever random value. I want these to always be different, but hold on, we're going to do the same here. We're going to get a random value based on our frame. So every frame it's different, but we want every point to have a different random value. That's the point here, and this is for our seed. So that both our random value and both of our random values give us truly random values, and there's no relationship with time. It just changes over time. Yes? Yes. I might add in another random value so that these aren't using the same random value, so that... Well, no, they're different data types. I'm overthinking it now. Let's move on. So let's plug this into our switch. And in the low chance that this is true, we want a different value. And we want actually a very small value. We're going to go with 0.025 and No, we're going to go with negative 0.025 and 0.025. I might need to change these values, but essentially what we're doing is we're going to take our R value and add our random value. And if this is true, then we'll get a new R value, a mutated R value, if you will, to save to our R value on the newly propagated, our newly colonized cells. So now we should see swirling, like all of these things adding in new values, but also changing what value they are every now and again. And so we'll break out of these cells that were kind of in here. If all of that makes sense, let's just run it and see what happens. Okay. So we're spreading. Did it just do the same thing? Oh, there's a slight change here. So this is an example where it happened. Let's stop looking at the R value, actually, and just see what the normal simulation looks like. Oh, and also maybe go back to looking at our, where is it here? Set point radius. So, okay. Reset the simulation. We've got spreading. We're moving around. We're moving and grooving. We had a little bit of blue there. It's still going to peter out, though. Okay. Which tells me that we need to up the amount that we can mutate by. So instead of having these two values, since I want it to go either positive or negative, what we're going to do is just set up a value node. So this will be the amount that we can change, and then we'll add in a math node. Switch this to multiply. We'll multiply by -1. Plug this into that into the min, and then this into the max. So what we've got going on is we've got one value that controls both the minimum and the maximum, and it'll just create a spread of values centered around 0. Okay? So we had 0.025 in there before. Let's just double that and bring it up to 0.05. See what happens. Hit play. Oh, we might also want to change the random noise. Ooh. Okay, we had some variable. Okay. It's still not enough. We're just going to double it again. Say that it's 0.1. We'll see some spreading. We should see... Oh, actually. Well, this is good. Ah, okay. Hey, look at that. We have reaction diffusion happening. This is great. It's interesting that we have some patches where it's just not going. I guess it needs to increase the value a little bit more. But anyway, this is kind of the pattern that we're going for. This is not exactly what I want, because this becomes heavy to process and it's so repetitive, it's uninteresting to me, personally. I like more noise and more organic movement in these simulations, but we have it where it's able to invade in on its own pattern and propagate waves outward. It's so good. Thank you. Yes. Wow. I am so happy. Oh, and I don't know why. Hey, hold on. Hold on a hot second. I just read your name. I thought I had read it earlier. Excuse me. Quadrivium. Hello. Hello. Uh, I love that name, partially because, that's one of my favorite books. Uh, let me, well, change the camera. Quad, whoop, whoop. Quadrivium. It's a good book. It's one of my favorite books. I was introduced to this series of books. I have Quadrivium and Scientia sitting here on my desk. They give me a lot of inspiration. Like, they're not deep dive books into heavy topics, but they're really good for introducing a lot of stuff. Anyway, I'm sorry. I just noticed that name. I wanted to mention. Is it's a good name. Good job. I'm sorry. Let's switch back to working on this. So, I love these patterns. Awesome. Hey, thanks. So these patterns, not the most interesting. It gets heavy to process. What I was doing was increasing the amount that we can mutate. What I should be doing is increasing the likelihood that this mutates. So let's turn this value down just a little, well, back to where we started. And we've more than doubled? Yeah, more than doubled that value, and now we should see them propagating a little bit more easily, but not necessarily getting into those swirling patterns. Although it is very easy for this to get into that kind of swirling pattern, as you can see. It's also fascinating that we're getting... Yeah, I think we need to change the initial noise, because we're getting a lot of these same kind of patterns and big open dead areas. I've actually never gotten these open dead areas before. This is new and interesting. And are we gonna get... Nah, not within our simulation time. Okay. But that relates back to the initial noise that we set up. So let's take another look at that. And change probably the W value as well as the scale. Should we increase that scale? I feel like we should decrease it, right? Oh. We should not multiply that by 6, but multiply that by 3. I forgot that since we're not normalizing this, our noise is centered on 0. So we were going from -6 to +6. That's a large range. And I think it was just playing in the positive, well, either the positive or the negative space, doesn't really matter. And not touching the other one because the distance was too great. This is fun. You guys get to see the process and the ideas happening in real time, right? Like, I've already done this before, so these aren't all new ideas, but I'm just remembering, right? Because I said a while ago, probably half an hour ago, we have this set to less than or equal because we needed that to just get it to work. Now that we've increased the range, we should be able to invert this again and still get interesting visuals. So we're going to go greater than or equal because we have a larger range. This was the key thing we needed, was to just expand the range of the values on our initial noise. So, well, I can't hit play when we're looking at this. So if we hit play, we should see absolutely nothing again. Okay, fine. Uh, there's another way we can go about this, and that's to uh, duplicate this, take our random selection that determines whether or not it's alive, and what we'll do is just add some amount. We'll take that, add a little bit so that there is a greater difference. There we go. Okay. Because our initial points are since our white noise, No, our noise texture is essentially Perlin noise. All of the values around all of our living points are pretty close to being the same. And we don't want that. We want at least our initial points to have a greater difference between them and the ones nearby, but we want the gradients of the global R value to be pretty smooth so that they can propagate from one region to another, right? So we just have to increase the R value of our initial living points, and then they have enough difference to start colonizing, but the world has enough gradient to let them propagate. So we've done that, and now, finally, this is all working up to snuff. This is essentially the simulation I wanted to make. We have some values we need to tweak. It's not going to look exactly the same, and there is a little bit of cherry picking involved, okay? So, like, that didn't run so well. It didn't run very long. It didn't really get into a cycle that it could continue with. So we change the W value. We change our seed value. We maybe set up an integer value that can drive both the seed and the W value. Wow, would you look at that? So now we have one value to tweak instead of two. But okay, so we've got, oh, that's gonna die. Yeah, sad. But that's the kind of pattern I want to see pop up. Let me make this bigger so it's easier to see. We want to see this spread with a big gap, and so it can circle it back in on itself, but that did it too quickly, and the values weren't able to mutate fast enough to be able to spread to regions that it couldn't access before. So, again, we can either mess with how much everything changes. Let's bump that up a little bit more because we just bumped up the mutation rate, which is the other way we can affect that, at least at the moment. Because from here, once we get something that's stable with just these variables, we can start adding on variables. Like we can add variety to the maximum age and make it so that they can mutate into wider waves and shorter waves. That one's interesting. I want it to be more interesting. In my own testing, it kind of fizzled out a little bit. But you can get that. I want to figure out how to layer different simulations like these together so that we really do have multiple species that interact, because these are kind of all the same. Like, their values change over time, but they all have the same rules, right? I think it would be fun to get another simulation layered in here that has slightly different rules. Anyway, I'm talking about future things. Let's just see if these values work better. It looks, well, no, not quite. So let's change our seed. Actually, something I could do is bring in an input node and put that in there. And let's just label this seed because, again, I'm trying to be organized. I'm gonna get rid of the geometry. I'm not gonna get rid of the geometry input because one of the fascinating things about this simulation is how much it's tied to the topology. Which reminds me, there's another way we can make this more interesting. We can add in dead zones, artificial dead zones, which help break up those rippling patterns and also force them to break up and diversify before coming back together. I'll show you what I mean in a second. Right now, let's just play around with some seed values. So let's go to the modifiers panel. We have this seed value. We can just kind of close off geometry nodes for a hot second and just fiddle around. And just bring up different seed values, see what happens, find something interesting to look at. Because that is the whole point of this. It's to make art. It's to find interesting patterns that like are just satisfying to look at. Okay, that kind of tells me we're not quite there. It's not propagating just enough. And why is that? Maybe we do want to increase that to 6. Let's just see what happens. Oh. Yeah, that one change, and now suddenly we have all of the reaction diffusion happening. Look at that. Again, not really what I was going for, but oh, and it's so much fun too. Like if we rewind here some, we had 2 of these like swirling areas where all of these like waves propagate from, and then something happened. I'm not exactly sure what, but that one died out, and now this takes over, and it's so dynamic. It's so dynamic and cool. Oh, and the reaction diffusion broke. And everything dies. Yeah, so that's telling me something about this simulation isn't as stable as what I'm going for and what I've managed to achieve in the past. So we need to play with it a little bit more. Nature is a procedural artist for sure. Very true. Incredibly true. Oh man, you have no idea. Like, oh, I'm excited to be talking about this. I'm excited to be talking about life sims because nature is just incredible, and I want to show how things like this directly relate to nature. Like, we haven't even talked about instancing geometry on any of these points yet, right? We could take we could create another geometry nodes network, and by introducing more genes here, we could have things like, I don't know if anybody in chat is familiar with Spore, ideally, because that was a great game, great part of my childhood. Spore was so much fun. We could have, like, I imagine these kind of like algae or plants or even mushrooms, like spreading out. Mushrooms actually is a very good analogy. Like fairy rings, if you've ever heard of those, the like mushroom rings. As a mushroom like starts growing in the ground, it'll eat up the nutrients in the soil and spread out in circles. And the mushroom itself, the reproductive part of the fungus, they'll pop up where there's the most resources, where there's the most nutrition, because it's effectively eaten everything it could in the center, died there, and spread out in a circle. This is the geometry of life. Mushrooms growing outwards in circles because they've eaten the nutrients in the middle, and then spread out. Like this looks like, it looks a lot like fairy rings, or what fairy rings on a sphere where they can't eat all of the nutrients perfectly in a circle, what it looks like. So we could take these genes, use them in a procedural workflow to create some geometry to represent mushrooms, and have different mushroom shapes based on those genes, and those genes changing the shape, but also like impacting the rules of the simulation so that they can and can't propagate in different areas. Like this is how you do that. This simulation can represent so many different things in nature, and I'm so excited to do exactly that. Totally seen those in the forest, mind-blowing. Absolutely, I'm glad you're on the same page. It's so good. I also found out recently sequoias and like trees also form fairy rings, where one will die, but like it'll have offshoots on the outside, and then the like one where a tree gets like cut down, it'll still be alive underneath, and so it'll send shoots up around this like giant sequoia stump, and then you'll have a ring of sequoias grow up, and eventually as they get bigger and whatnot, kind of survival of the fittest. The best surviving shoot of that sequoia will be the one that grows to be thousands of years old. But in the interim, you can get huge rings of trees, and that's also mind blowing. Anyway, getting back to this, uh, yeah, I kind of want to keep tweaking this just a little bit. Also, did the music just stop? No, it did not. Okay. I want to keep tweaking this and get this closer to what I was going for, but this is essentially the simulation. Everything else that I showed in the other version that I was referencing is this plus more. Effectively, it does all the same thing, but with less organization and with more redundancy, because this was me actively trying to figure out how to do this simulation. So there are a lot of redundant nodes in here that, as I've gone back and redone this a couple of times, I've figured out we only need about this much. And this just looks so much cleaner to me. So yeah, I kind of want to tweak the initial values here a little bit, just to see if we can get something that's a little bit more sustainable. And then yeah, we could try and make some additional, again, genes. I keep putting that in air quotes. It feels important to put that in air quotes because it's not really functioning like genetics, but it's inspired by genetics. But yeah, it could be fun to introduce more that affect the rules, but as we start changing the rules, it'll be harder and harder to see how everything's affecting one another. Or, well, I don't know. What would you guys like to see? This is the bulk of what I wanted to do. Everything from here on out really is just kind of tweaking everything to get more interesting dynamics. So yeah, I'm just going to play with some numbers for a moment. Let me know if there's a direction you want to see this simulation go, or if there's something else you guys want to see. I think, topology would be a fun one. I like doing this not just on a sphere. Planes are difficult in my opinion because a lot of this is founded on it wrapping around itself, being kind of on an infinite surface, if that makes sense. Like, it's a finite surface, but it has infinite, or sorry, let me rephrase. This is a boundless surface. Spheres are boundless. There's no edges here. So this simulation, it kind of hinges on the fact that it can just kind of wrap around itself and keep going. But that also means that other topologies that are also boundless, so like a torus, have different interactions that we can get. Ooh, and just... No, I think this is the simulation we saw a moment ago, because all I did was change the scale. Let's change the seed again. See if we can get something more interesting happening here. And like I said earlier, a lot of this is... It kind of comes down to cherry picking. Like, you play around with the seed, you tweak some values, eventually you find something more interesting or find things less interesting. Sometimes they just die out, sometimes they keep going, sometimes they do the reaction diffusion waves where it just swirls infinitely. Let's actually adjust this value. Let's increase it. Let's go 0.75. Or no, that's not the value I want to affect. We could increase the amount of difference required. See if we get something that doesn't die off as quickly or go into spirals as quickly. Never mind, we're leaving it at 1. Yeah, what else can we adjust? We could increase the mutation rate, see if we get more interesting things because they can just diversify a little bit faster. Actually, there is one thing we can do. So something I did before realizing I had made a mistake in an older version was to take the amount of living points. I think it was divided by the total amount of points, and use that as the probability for mutation here. And the idea being that the more points you have, the less, I think it was the less likely it was to mutate, and then the fewer number of points, the more likely, so that if there were only so many points, like it was getting ready to die, it would diversify faster and spread to different regions a lot more easily. And we could play around with that. Let's get a map range node, because I found that pretty interesting, and it's kind of a cheat to getting more sustainable simulations. In fact, that is what we have going on here. This is again a slightly older version where I didn't quite have stability broken or figured out quite yet, so I did literally just kind of force this to balance itself to find good rates of mutation. But taking another look, let's get, so the total amount of points is going to be our max. We're going to take the number of living cells as our current value, and we're going to set that not from 0 to 1, but let's go from like 0.25 to 0.1 for our probability. And now we should see, it won't be immediately apparent, but it should help stabilize this simulation because it was dying pretty quickly. It should be able to come back from something like this where it's about to fizzle out. Nope. Okay. Let's get a different seed then. Oh, nope. That one also doesn't work, and now I don't know if it's because of the change I just made. Wait, all the action was on the back here. I don't know if it's because of the change I just made or because something else. Let's see. Yeah, we can see the colors changing. Okay, first off, let's get rid of that, because it feels like we were having a lot more luck before. I guess we could change those values, but let's affect the scale. Well, we could turn the roughness down. That might help us out a little bit. We don't necessarily need rough noise, we just need some noise. Ooh. Oh, that almost did it. Let's turn up the mutation rate then. Or let's actually turn up the amount that it can mutate by. I guess another thing I've done in the past is just given this a positive mutation, so it would... Yeah, we're gonna do that. And that brings me back to a point that I never followed up on earlier in the stream when we were setting up the material. I said we need hue saturation value. I'm getting ahead of myself in explaining that, and I just kind of hand waved it away. Part of the reason why we want to do this is because it's easy to take a random float and turn it into a color. The other part is because by feeding in hue will wrap around on itself. If we start with a value of 0 and just increase that, wait, that's... Let me see if we can bring in some points here to take a look at. Okay, so all of these are red. at the moment because nothing's driving change in color. That's because our hue is 0.5. And as we, let's do this a little slower. As we increase the hue, it'll go all the way up to 1, which is then going to show cyan, the opposite of red. But we can theoretically type in a value greater than 1 and we'll get red again. It'll wrap around on itself. So if we take our factor and back in geometry nodes, instead of min-max this being negative and positive, let's make it just 0, so there's a small chance that even if it does mutate, it won't do anything. And then the max being 0.075. And now all of those values will just increase, and so we'll get this rainbow effect where it only increases, and the colors are just a little bit more satisfying because they don't split off as much. And this is purely aesthetic at this point. This doesn't change the simulation whatsoever. I guess it does change the simulation some, but it's most... Sorry, I'm thinking through the ramifications of changing this value. Yeah, it does change the simulation. It changes the simulation and the aesthetic. But we'll go from yellow to green to blue instead of sometimes the yellow going back to red. Which is just neat. Let's cycle through some more seeds here. Ooh, that was fun. We had a hole in that wave, which let that propagate a little bit easier. But yeah, something's going on. We should see more... They're like dying off a little too quickly still. Why? Do we need a greater initial difference so that they can spread more? Maybe. Yeah, there's some little detail in this that's just keeping it from being as self-sustaining as I want it to, because I have our max frames turned up to 1,000. We're not often getting beyond 250, and in my testing I've gotten simulations that run 2,000 or 3,000 frames before they die, or if they even die. So something is slightly askew. I'm actually going to close out of this version so I can reference another version that was more self-sustaining. Give me a second to get that to reference here. Okay, this version. Let me see if I can spot just a quick change. Actually, for reference, this is how messy this one got. So, oops. It's fine though, but I am gonna borrow a take from that one. And we're going to break up our initial geometry some. So, we've got our icosphere. We're going to compare the position, and we're going to make it so that if points are within some proximity of either pole of the sphere, we're just going to get rid of those points. And what that will do is create this natural break where they have to wrap around that gap, and in that time there will be enough difference that accumulates in the mutations so that when they come back together it breaks the wave and it doesn't just cycle back to where it collapses, if that makes sense. So give me a hot second. We're going to take the position, we're going to separate the position into X, Y, Z. We're going to take the Z, and if the Z is well, the absolute value, this is another... We need the absolute value so that we're deleting both the positive and negative Z. If that is greater than 0.95 just as a value, then we're going to delete geometry. And we want to do this for our points. Yes. Yes. Okay, so now we should have some values up at the top here. I guess this isn't the best. Ah, there we go. Okay, so we gotta break. That one's still gonna peter out. What the heck? Let's try that again with a different seed. See if we can get something more interesting. And I think we got it. I might have spoken too soon. Well, we got wave propagation, which is pretty darn good. That's pretty darn good. All in all, I'm pretty happy with this. There are tweaks that I have done, and tweaks I will continue to do, I'm sure. At least this one's self-sustaining, and it's actually running really well. Usually when I get to the point where these waves are covering the entire surface of the sphere, it gets a little weird. It gets a little laggy. Things just don't propagate as well. I'm thinking too many things at once. It's not that they don't propagate as well. It's that my machine just lags out because we're doing too many calculations. But fortunately, by breaking out this propagation check and just running the repeat zone over fewer points, we're able to get more points doing interesting things with like just better, like with it's more optimized. That's where I'm trying to go with this. But yeah, that's neat. I left the geometry open though, so what if we take our icosphere? Do I want to do it that way? I'll give us a switch. I want to introduce different topologies now and introduce the ability to put this on any geometry and not just default to a sphere. We're still gonna default to a sphere, so we're gonna say put our icosphere in this switch as false so that it defaults to using an icosphere, and then put our geometry inputs into true. So now we have this toggle to be able to put this on a plane or whatever the heck else. Like we could put this on Suzanne, right? So let's put this switch, put this in here, and now we can start playing around with other topologies. So let's close that out. We're going to bring up, honestly, let's just bring up Suzanne. Turn off the plane, so we're not simulating that. We're going to subdivide Suzanne here. Subdivide surfaces. We'll do it twice. Shade smooth, because of course. And now let's add our geometry nodes. And switch so that we are using Suzanne. And let's get some reaction diffusion happening on Suzanne. Oh my god, also, we're gonna save this. I can't believe I did it again. I need to... Wait, no, tell me I didn't just do that. I might have just accidentally saved over an old file by accidentally double-clicking. That's gonna be problematic, but you know what? I will deal with that later. We got got this saved. Okay, cool. Now let's simulate on our monkey. Yeah, something's... I'm sorry, I gotta play around with this, because it's just not... Like, something about our noise is just not working well enough. I don't know what it is. Like, it just keeps fizzling out, and it shouldn't do that as much as it is. Like, it should be a lot easier to get self-sustaining, not repeating, but self-sustaining organic patterns. Why? Yet again, I'm just asking myself, why? We're going to reintroduce the minimum value here, see if that helps a little bit. And then if not, I'm going to increase the amount that, that we can mutate by. And then if that doesn't work, it might be a topological problem. Just change the seed. We got a lot more on the initial geometry that time. Okay, we've got a self-sustaining squirrel. Yeah, and I don't think I like how... Well... Okay. Our swirl moved, which is nice. Yeah, that's a lot. That's just a lot of color. We got to turn that back down. That's not... I'm going to actually reduce it some, because I don't love it when we get a lot of little teeny patches of different colors. Also, I'm sorry. I did not realize my stream got offset. Like my capture got offset. I don't know how that happened. Sorry about that. Anyway, we have got Suzanne. Let's just see what happens with less diversity in the mutation rate. It looks a little bit better now. We don't have wildly different colors. Still got that swirl going. There's a lot more action than I'd like to see. Yeah, there's a lot going on there. Why are we... Well, let's decrease that. Yeah, like I said towards the beginning of the stream, there are a lot of variables that you can use to tweak this simulation. And a lot of it is just kind of tweaking, figuring out what works, what doesn't work. I do a lot of tests to just isolating those variables and seeing how much has changed. Like, I use the snipping tool a lot to say, okay, at this frame it looks like this, and here's the reference. Now let's tweak this variable just a touch, see if we get the same, or if we get a big enough difference. And that like more scientific approach really helps figure out what's going on. I'm trying to save that time here, but maybe I'm not saving much time by just willy-nilly playing with the values. Regardless, it's a fun simulation. We got it to work. We have it on different topologies. I kind of want to bring in a Viking knot. I think that's what it was. I think that's what it's called in here. Yeah, let's turn off Suzanne for now. Let's bring in more Tauruses. Where is it? Mesh. No, that's not it. I want... Oh, do I not have that plugin enabled? I don't think I have the plugin enabled that I thought I had. Regardless, let's just do it on a torus, on a normal torus. I was hoping to get a Trinity torus, and we'll do that in a second, but I have to enable the extra objects plugin because upgrading to Blender 4.4, I haven't imported all of my plugins yet, I guess. Anyway, let's add geometry nodes. Turn on our switch. Let's just give it a crazy seed, something we haven't seen before, and hit play. Yeah, I don't know what I was expecting. It'll, of course, inevitably hit itself because it's a torus. It'll just kind of go around the ring if it doesn't split off into two parts and hit itself. But that's not a given. Let's try this again. Yeah, that's less entertaining. I have had like an interesting one where one ring kind of starts going around the torus. So I want to see that happen where we have 1 point, or sorry, one like ring that just can continuously go around. Is that, oh, there we go. Okay, we've got, what? Something is wrong with the noise. Like, we're not, why aren't we able to wrap around? Let's actually investigate this a little bit more by looking at the, what is it, the R value. I want named attributes. We're going to pull up R. Pull that up. Oh, and we have to turn off the set point radius. Okay. No, that's not how we did it earlier. We modified the shader. Hold on, give me the sim mat. There we go. And we're going to ignore mix. Yeah, that's what it is. Okay. Let's just see how these colors propagate and if they're overlapping each other. They're still not, and that's the problem. Why? Why isn't this like pinkish color spreading into the blue? That's a huge problem, and that's a crucial part of this simulation. Why is that still not happening? What the heck? That's like the last thing I want to figure out, because that was the first thing I wanted to do. So let's figure that out. Okay. What is it about our values that's keeping this from going into here? Yeah, let's take a look. I just want to take a quick look at an older version, make sure I'm resetting the values right, because that was an issue earlier. Yeah, age greater than max age. We reset live and age. Give me just a hot minute. I want to see if I can debug this, but Yeah, what the heck is going on? Honestly, it might just partially be, well, everything in me, everything is saying that our initial noise is just not it. Like, and I don't know why that would be. We should have those. Yeah, okay. So those are taking over, but then it doesn't continue to take over. Why? Like, watching this orange, okay, it spreads over here, and then this spreads over this way. That's so strange. Why, like, it almost filled in the same color. What the heck is happening? Let's get rid of this min, so we're only, we're kind of ratcheting up the R value as things go through. So as this comes in, it should continue to increase, and then it matches the same value. What? We're just gonna get a new seed. So we've got blues spreading, and that's it. Change our value again. I'm becoming perplexed. Okay, so we have these waves. And then it just hits a wall. It should be able to overcome that. I don't get it. Let's decrease this maybe. So we have less spread in the initial values. I don't know that that's gonna do anything. There's some little detail that I'm missing, and it's gonna hit me as soon as I wrap up the stream here. Which is so upsetting because like everything else is working fine for this. Absolutely everything. But it's just not able to sustain itself that once everything that can be colonized has been colonized. Why is that? Why is it not able to sustain itself past that point? Also interesting, their tourist decided to be black now. Don't know why, but that's fine. Huh. Like, this looks like a promising one, right? That should just keep going, but it'll hit a wall here in a second, right? Yeah, I don't see any reason why that shouldn't have kept going. Maybe I really do just need to increase the amount that it can increase by? That doesn't feel right. Let's see, where is that value? You know, we'll add... Oop, that's not the spot that I wanted to do that on. Where are you? Well, let's get rid of that test. We don't need those nodes. Let's get rid of this. We're going to increase that to 0.1 and increase that to 0.05. And that might help out if both of these are in the positive. And if this goes around past here, we'll know that we've done it. We've not done it. Yeah, I don't. We're just gonna up the probability by a lot. Let it go crazy. Just let it absolutely go buck wild. Yeah, that's working fine. I think the simulation is working fine. It's just there's some tiny detail that's different than before, but not technically wrong. Which is infuriating. Absolutely infuriating, but that's all right. We got it to work. We got it to work with without getting into a lot of the weeds and nonsense I have been getting into. Like I said before, I've added several other variables in here that didn't really affect the simulation all that much. So we didn't need, or I was able to ignore a lot of things that we just didn't need, which is really nice. And we got a very pretty visual here. This is beautiful in my opinion. I love simulations like this. Oh yeah, now it's, there we go. That's the kind of simulation I wanted to show on a Taurus, where it's able to sustain itself at one end. Well, I was talking about one ring that could just keep going around, but this is another pattern that you only get on a Taurus, where it can kind of generate at one end and then it crashes back together at the other. It's so good. It's so incredibly good. And this is just a really fun simulation for lots of different topologies. If I can do just one more before we wrap up the stream, there's another that I really like, and we might need... Well, no, we can do it on a cube. I like to do it on a tetrahedron, but if I don't have the extra objects add-on, let's... Preferences. Let's just get the add-on real quick. I thought I had imported it already, but we want the extra mesh objects add-on. Give my computer a hot second. Okay. So now that we have that, we can go here and there we go. There's all of the extra objects I was hoping for. So like we could get a Taurus knot. This one's really fun. Let's add a subdiv. Shade smooth. And then we'll add in our geometry nodes. Give it a random seed. And watch that go. And now we have so many more points that now my computer is chugging along. So, oops. But yeah, this is really effectively the same topology as a Taurus. Like, it's a knot, so it doesn't have... So it has extra properties, but as far as the surface goes, like, things will just kind of wrap around the same way we were looking at with the simpler Taurus. So let's actually get rid of that one. And instead, I want to take a look at our... Where are you? At our math functions. We want regular solids. We're going to take the tetrahedron here and add in a few different modifiers to poke some holes in it, really. So let's see, I want a wireframe. Then let's do a skin. That's not exactly the geometry I want. Let's do some branch smoothing. Yeah, what the heck? Actually, what even? Wait, why did you disappear? What? I want wireframe. And if this doesn't... Oh, skin. Okay. I thought wireframe was just going to give me the edges. This shows you how often I use modifiers. We just want the wireframe. We want to increase the thickness here. And then I want to add in a subdiv. So that we get this kind of smoothed. Give it quite a few subdivisions. I want this smoothed tetrahedron that I find nice to look at. Let's actually increase that just a little bit. So now this is like the Taurus where we have these like openings, but it's got more connections than just a ring, right? So now what we can do is add in our geometry nodes, use our switch, random seed, and let's see what happens on this topology. And again, it just fizzles out. Ah, you're killing me, Smalls. I want to show how it's interesting, like it can split off, and then on the inside some can continue, uh, but and like make it so that it's easier for things to just continuously propagate. Let's try one more seed, and then I'll affect the noise if this just continues. Ah, okay, that's what I was hoping for. It wraps around on the inside, and then it's easier to get some self-sustaining patterns, which is really fun. Like, look at that. That's so cool. And then, of course, it dies out. But while it's going, that looks really fun. It looks really fun, and I enjoy it a lot. Let's turn down that probability again. Maybe down to a 0.1 so that we get less crazy of colors. Yeah? Okay, it is running. There we go. And just play with the seed value, I guess. I have gotten it to where this is much more reliable, and it is driving me nuts that it isn't. But c'est la vie, I suppose. Fortunately, it can still be interesting if we just play with the seed values. But yeah, different topologies, very fun, very enjoyable to just play around with this sim. So yeah, I think that is, well, hold on. I want to get one I just want one that self-sustains for longer. Just give me one blender. Cuz I really like it on the tetrahedron. It's so satisfying when it works. Yeah, I guess I have to turn the mutation rate back up. All right, you win. We'll leave it at 0.2. It'll get a little crazy with the colors, but that's fine. Okay. But yeah, that is largely what I wanted to discuss today. I'm so happy that it works. You know, we're gonna adjust this so that it loops. And actually, I'm gonna bake this so that it can my RAM can have a little bit of a break. Yeah, I guess that is one more thing that I haven't mentioned is I usually just put a bake node in towards the end of the simulation, set it to animation, and then you can just bake all of this out. It'll take a minute or two to do that, and then you can, you know, adjust all of the aesthetics at this end of the node setup without having to resimulate, or you can even set up multiple bake nodes with different parameters and seeds and things, and then switch between them afterwards. That's always fun. But yeah, we can just let that play for a moment as we talk, because I love this simulation. It's super cool. There's a lot that can be explored with it, and I can't wait to show you guys a lot of the future plans I have for this, because like I said a couple times during the stream, I really think it's possible to layer these together. I haven't found a good way to like sum up this entire node network, like group all of these into one node with just a bunch of parameters so that I can stack it. But that is a goal, is to kind of generalize this, make it so that I can come up with a few different rules, toggle them on and off, and get some of the different dynamics that we see in nature and in ecologies, and kind of build an ecosystem. Like I could directly try and simulate, I've had tide pools on my mind a lot, so like simulate the growth of different barnacles or clams or mussels and whatnot on rocks, along with like kelp growing up, and then have starfish come along, and like the mussels would grow slower than this simulation is right now, but you could have like another point that wanders over the surface that kind of just eats them, and if it doesn't find enough to eat, then it dies. And it would just kind of carve out trails where these points don't exist anymore. I think that would be super cool. And honestly, now that all of this simulation is figured out, it really wouldn't be that hard. It would just be taking all of what we've done and layering it together. So that's kind of my... I want to say my goal for this week. I don't think it'll take 1 week to figure that out, but I'm going to be working on that a lot this week. I've also been working on plate tectonics and simulating gravity, so there's a lot that I can't wait to share with you guys on stream and in videos. But for now, I'm going to wrap up just a little bit sooner than I expected to. I wanted to go to noon, but we've kind of talked about everything that I had, really. Everything that I had prepared for today was really just getting this to work, and we did that in 3 hours, which is pretty good. So I'm going to leave it there before I start going off the deep end into trying out things that I don't know if they work or not. We'll save that for a future stream, but thank you all so much for watching. And just a real quick mention, I have a Patreon. I have a free blog on my Patreon, so you don't even have to pay anything. You don't even have to become a member to read that. That is open to the public. Check it out. I talk about this project, Game of Life. I've been playing around with Mandelbrot. I did a lot of Mandelbrot stuff and fractals over the summer, which was really funny. You can check that out there. I did a couple different ways of doing that in both Geometry Nodes and in shaders. So check out Patreon if you're in a place where you can donate to that. My patrons get early access to videos and access to my project files. I probably won't upload this one because I've already uploaded this this general project for my patrons to check out, so I won't be uploading the stream one because this one isn't all that new to them. But in the future, there will be more project files coming their way, so if you're interested in that, definitely consider it. I'd appreciate it. And to my current patrons, thank you all so much. You guys are wonderful. And anybody who is left at this stream, thank you all so much for watching, for tuning in. Anybody who's popped in and out, you guys are all incredible, and I appreciate you just checking out what I'm up to. It's been fun. It's been real. And with all of that said, thank you so much for watching, and I will see you in the next one. Bye.